Good afternoon, everybody. I just wanted to record a brief lecture to finish chapter three. Since we did miss um, Monday because of Labor Day, I wanted to at the very least give you an opportunity to see what we're going to be doing for the rest of chapter three, and hopefully, if you have any questions, we'll go over them on Monday. But we're going to start on chapter four on Monday. So I wanted to go ahead and record a lecture to again finish chapter three. We'll talk about the median. We'll talk about the mode. Um, Not too much complexity in these two concepts. We did finish talking about the mean, and I spent a little more time on the mean to give you the kind of the background and the reasons why we use the mean. And then for the rest of this chapter, we'll talk about the median and the mode, and then when you would use the mean, median, and mode, depending on the type of data that you have. And so we'll talk a little bit about that after this lecture recording. I'll go ahead and post this. You should be able to complete the homework, which will be due. I updated that due date to uh, I think Wednesday, 11:59 p.m. next Wednesday. And then also, I'm going to probably get the practice problems to be due on Monday, just so that you can use those practice problems to then complete the homework that'll be due on Wednesday. Okay. So things will be pushed back a little bit, but I think we'll be able to get through it with no issues. But again, if you do have any questions, you can ask them in class or come to office hours. Again, my office hours are Monday and Wednesday from 12 to 2 p.m. and then Tuesday and Thursday from 9 a.m. to 12 p.m. So again, please come if you need any assistance. All right, so let's go ahead and get started. I want to talk to you a little bit about the median. Okay, we talked about the mean, the median, and the mode. Those are central tendency measures, and what we're trying to do with central tendency is determine the middle, and the single most measure of that best represents the distribution that we're interested in. Okay, so if something is normally distributed, then we'll likely just use the mean because the mean is probably the best representation. However, if we do have some outliers, like we talked about, say for instance, for income, where we have some billionaires who make a lot of money and their net worth is a lot higher than the average income for the United States, then we'd probably want to use median income because median gives us that middle of the distribution. And so the median serves as that midpoint of the scores in the distribution, right? So what we do, you list your values and your scores from least to greatest, and then you find that middle value. And we talked a little bit about how you do that. We learned this earlier on in our math career, where you line them up, find the middle number, and then select that middle number. That middle number is the median. When you think about the median divides the distribution in half. So you have 50% of the scores of the distribution on the left-hand side of that median and 50% on the right-hand side of that median. So it splits it in half, precisely in half, okay? When you think about an odd number or odd number of scores in your distribution, all you do is line them up from least to greatest, and you select that middle number. That middle number in this particular case is 8, right? So again, very, very simple, especially when you're using discrete variables. Okay, discrete variables are again variables that do not have fractional parts, and you can't break them into fractional parts. But when you do have discrete variables, again, you're able to then locate the middle number pretty easily. Okay, so when you have the scores 3, 5, 8, 10, and 11, right, that middle number is the 8. Okay, when you are locating your median with even numbers, especially looking at discrete variables, you have to, again, order them from least to greatest or lowest to highest. In this example, we have scores of 1, 1, 4, 5, 7, and 8. So since there are an odd number, there's 6 scores, then you would have to take the two middle scores. In this case, it's the 4 and the 5. You would add those two scores together and divide by 2. And in this instance, that gives you a 4.5. So if I were to write this 4.5 on the number line, again, it splits the 1, 1, 4, and then 5, 7, 8, again, directly in the middle. All right. All right, let's move forward. Okay, so that was for discrete variables. Discrete variables do not have any fractional parts. However, when you are using continuous variables, it's important that we understand that you can break the numbers into fractional parts. And if you can break the numbers into fractional parts, then you will have to then be able to divide the median, and it has to be in fractional parts as well. Okay, so we'll go through a brief example, and I'll show you what that means. Okay, but again, the precise median is going to give me that precise number that's going to break the distribution into equal parts: 50% on the left, 50% on the right. The process that we use in order to get that exact estimate of the intermediate value between the two values that we're interested in is what we call interpolation. Okay, so we'll go through a process of what we do. Very, very simple. It's a formula that we'll have and use to do it. I'll take you through an example, and then we'll be able to move on. And again, if you see it in the homework, you'll know what the formula is, and then you'll be able to tackle that formula or that problem with no issues. Okay. So here is an example of an instance where uh, you have 8 scores, right? So 1, 2, 3, 4, 5, 6, 7, 8, right? This is a histogram, and it is in blocks, right? When you have a values that are continuous, with this example, you have a frequency of 4 for the score of 4 here, right? So you have 4 4s, right? That in and of itself, if I were to do a histogram for that, right? Or excuse me, do a median for that. That median for this particular example is going to be 4, right? 4 divided by 4, 4 plus 4, 8 divided by 2 gives me 4. So I'm going to share my screen so you're able to see, but this is an example that we're going to use because it shows me that instead of it being 4, the actual precise median is going to be 3.75. So I'm going to go through an example, which kind of gives us the opportunity to show that, yeah, I can get the precise median and it's not 4, it is actually 3.75. So let me share my a whiteboard, my screen, and then we'll go through an example for you so you can see what I'm referring to. Okay. All right. So let's talk a little about precise median. All right. So when you think about the precise median, okay, you have to first start off with the values that were given. And in the example that I showed you, you had an N of 8. Okay, let me bring that down a little bit. So you had an N of 8. Okay. And you had these scores. Okay. You had 1, 2, 3, 4, 4, 4, 4, and then you had a 6. So you got 1, 2, 3, 4, 5, 6, 7, 8 scores. Okay. If I were to do the median for a discrete variable, and we'll put discrete right here. It's pretty simple to find the median, right? So I'm going to take the 2 middle scores, 1, 2, 3, 4. These 2 are considered my middle scores, right? So I got 3 on the left and then 3 on the right, okay? So all I'm going to do here is 4 plus 4 divided by 2. 4 plus 4 is 8 divided by 2. Okay, gives me 4. All right, so that is my median. Okay, that is my median. I'm trying to pull this over so you all can see it a little better. All right, okay, that is for a discrete variable. For a continuous variable, so this is continuous. Knowing that I have 4 4s, right? This is not the precise median because it's continuous. I have to have a fractional part. And the fractional part is going to be let me write this out for you so you can see it. The fractional part is going to be the number that I need in order to reach that 50% of the left and 50% on the right. So in the example that we saw, I'm going to go ahead and draw this out. The example that we saw, we had 1, 2, 3, 4, 5, 6. Okay. So, and then we had on the frequency, we had 1, 2, 3, 4, all the way up here. Right. So we had 1, 1. And I'm just using what I have. We had 2, we had 3, we had 1, 2, 3, 4, and then we had 1, 6. Okay. In this particular case, that we know that we have upper limits and we have lower limits, right? So for our median value right here, the upper limit for 4, upper real limit for 4, URL, is in this particular case would be 4.5. Okay. The lower real limit in this particular instance would be 3.5. Okay. So between 3.5 and 4.5, we have the number 4, and it sits right there at the middle. And then it gets, this is the value X equals 4. All right. So I know specifically that I have, again, 4 scores, right? But what I have right now is I have 1, 2, 3 values there. And if I were to check this 4, I wouldn't be able to, because then that would be more than 50% on the left and 50% on the right. So I have to find a value on this number line here that gives me that fractional part that I can use. So then I have 4 boxes on one side and then 4 boxes on the other, right? So in our example, if I divided this down the middle right there, this is 1/4, right? So that's a fourth of every box that I have. So that's 1/4 of every box. If I go right here, that's 1/4 of every box. And that 1/4 of every box would allow me to be able to then calculate that half, that 50% that I need for the left and to the right. Okay. So in order for me to do that, I have to use a fraction. Okay. And my fraction in this particular case is the number needed to reach 50%. And that 50% is, again, 50% of the distribution on the left-hand side and 50% on the right-hand side, and the number in the interval. Okay. So the number in the interval okay. In our particular case, the number, or again, the number needed to get that fractional part is going to be 1, right? I need 1 box, okay, because I have 3 on the left already. I need 1 box in order to reach 50%, right? So I have 4 boxes or 4 scores, or 8, excuse me, 8 scores. Right now I have 3 scores that are on the left. I need 1 more box to be that 50%, right? So that is the 1, okay? The 4, or the number in the interval, is going to be 4, because this is the number in the interval right here. 4 is in that, again, that interval, right? And so you're going to then put 1/4. This would be 2.5 if you were to put that in decimal form. All right. So this is what happens, right? I have to get that section, right, of these values right here, right? So I have to make sure that I can account for that shaded region right there. And so this is what it's going to be. In order to calculate that, I have, okay, 0.25. Okay, that's the fraction I need in order to calculate and get that, again, that 1 box. And I already have 3, and that 3 begins at that lower real limit, which is 3.5 right here. Okay. And again, once I show you an example, it's going to be really, really easy. All right. So I'm going to add the 3.25, or excuse me, the 0.25, which is this shaded region right here, this area right here, plus the 3.50. Okay. And that should give you the 3.75. Right. So that 3.75 then becomes the middle point of that distribution where I have 50% of the distribution of the boxes on the left-hand side and 50% of the boxes on the right-hand side. Okay. So this is the precise median. Okay. All right. So again, that is how you would get the precise median given the boxes that I have on that on the for this example. All right. So let's do a real example that we would use and utilize for the text. All right. There are going to be 5 steps that I want us to follow. But here's our example. Let me show you the example that we're going to use. All right. So we have n of 8. And then this is our distribution. These are our scores. Let me get our scores written out for us. All right, pull this over here. And these are our scores. It's going to be 1, 4, 5, 5, 5, 6, 7, and 8. All right. So I have 8 scores, and I can see already that I have a tie, right? So if I did the discrete median, again, treating these scores as discrete, then all I would do is I would add the 2 middle numbers up, which would be here. Okay. So it'll be 5 plus 5 divided by 2, or 10 divided by 2 gives me 5. Okay. That is the median for treating the scores like discrete variable. Okay. However, if I wanted to treat these variables like a continuous, so let's show you a continuous way. This would be my precise median. Let's work through the example. Okay. So in order for me to calculate my precise median, I need and to work through several steps. All right. Need to work through several steps. The first step, or step 1, is I need to determine how many scores fall above the mean, or the median, excuse me, and below the median. So this would be that 1/2, right? So then I need to do this. This is what I would need to do. So it'll be times n. Okay. So in our particular case, I have 0.5 times our n, which is 8 here. And that should be 4. Okay. So I need 4 scores on the left-hand side, and 4 scores should fall above the median. All right. That's step 1. Step 2. What I need to do for step 2 is I need to count the number of scores, okay, that fall below the lower real limit of the tied values. So I have my tied values are my 5s right here. Okay. Those are my tied values. Okay. So in order to determine what my frequency, okay, of those scores that fall below the lower real limit, I have to determine what my lower real limit is. Okay. My lower real limit for the value of 5, let me backtrack that. My lower real limit for my value of 5, excuse me, is here, right? So my lower real limit, will be what? 4.5. My upper real limit is going to be 5.5. Okay. So now I know I got 4.5 for my lower real limit. I have 5.5 for my upper real limit for the value of 5. This is the tied values. Okay, that's the tide. I got five, I got three fives, right? Okay, so let's move on. So it says the frequency of the scores that fall below the 4.5. And so my 4.5 is located right here. Okay. And so I have two values that fall below. So the frequency of those values or those scores that fall below my lower real limit are going to equal 2. All right. That's step 2. Step 3. Step 3 says that I need to find the half, right? So it'll be 0.5 times n minus the frequencies below my real limit. So I'm finding the difference in my step 1 and my step 2. So I'm going to get 4 minus, in this particular case, is 2, which gives me the value of 2. All right, that's step 2. Step 3, step 4 is I need to divide, okay, the frequency of my tide. Okay, so my frequency of my tide values, which is going to be 3 because I have, again, if we go back up, I have 3 fives. So that's my frequency of my tide values. That's going to be 3. All right. So in this particular case, I'm going to divide step 4 into step 5. So that'll be 0.5 minus the frequency below LRL or lower real limit divided by the frequency of my tide values. And in this particular case, I'm going to have 4 minus 2 divided by my frequency of my tide values, which is 3. Okay, so in this particular case, it's going to be 2 over 3, or be 0.67. I rounded to the 100th place. All right. All right. The last thing in step 5 is I got to put everything together. Okay, so this is the value or the formula for step 5, and this is our value that we're going to be using to get our precise median. Okay, it's going to be the x of our lower real limit plus 0.5n minus the frequency of those scores below my lower real limit, frequency of my tide. Okay, so now I have to locate again, the x value for my lower real limit. That's going to be this 4.5 right here. Okay, so I need to do this 4.5. That's this value right here. Okay, if we go back up, that's that value right there, that 4.5. Right. So now I know that that's 4.5. I'm going to go here. I'm going to go ahead and keep the same. So it'll be 4.5 plus. I'm just going to plug everything in that I have. That's going to be 4 minus 2 divided by 3. Okay, let's go ahead and do the math. That's 4.5 plus 2 over 3, which equals 4.5. That'll be plus 0.67, which would give me 4.5. It's going to give me 4. Oh, excuse me, not 4. It's going to be 5.17. Okay. So again, it's just 4.5 plus 0.67, which gives me 5.17. So this value right here is the value that I have. Okay. That's my precise median. All right. You're going to be given a practice problem that will have you locate the precise median. Again, you're going to be using this formula And you just have to go through and determine as we went through, go through my steps. For step 1, 0.5, 0.5 times n, or 0.5 times 8 gives me 4. Okay. You'll do step 2. All of my frequencies that are, my scores that are below my lower real limit, that's going to be those 2 values. Because if we go back up, those are the 2 values here, 1 and 4. Step 3 is you're taking your step 1 value and you're going to subtract your step 2 value from it. That's 4 minus 2 gives you 2. Your step 4 is you're looking at your tied value or your frequency. You're going to go here. So this is n equals 3 right there. That's 3 values of 5, right? So again, all I need now is to plug values in. And then the last thing is, if we go down, this value right here, that's going to be the 4.5. That's going to be that lower real limit, or that interval lower real limit, that I'm going to then plug in. So I'll plug all those values in, and you should get 5.17 after plugging everything in and solving for that median. All right. All right. So that is precise median. Okay. That's my precise median. Again, we'll go over an example in class if you need one. But again, there's a practice problem that we'll have you work it out. So again, be mindful of that as we move forward. But again, you won't be using this too often, but it does and is needed when you have continuous variables and you have numbers that are tied, that you have to utilize the precise median in order to determine what that value is. And it necessarily don't have to be, it could be a large number of scores, or it could be a small number of scores. But again, you want to get that fractional part that we get when we are using continuous variables. All right. Again, if you have any questions, we'll go over that again next week. But again, work through some problem, the practice problem, and then we'll go over that and discuss that in class. All right. Let me go back to my slides so you can, let's go here. Okay. So again, with these slides, again, just go through, work through that example. But let me go to the next slide. And again, here are my steps. You're going to be using this formula down here in order to find that precise median. But those steps are the same. The interpolation, formula is located down here. Okay, it just took you through some intermediate steps to get there. All right, so it says the mean, median and the mean and the middle, right? So there are going to be instances where you probably shouldn't use the mean, because the mean is not necessarily the middle of the distribution. And oftentimes that happens when maybe you have skewed data. And when you have skewed data, you're probably better off not using the mean. You're probably better off using the middle number, or the median, because that actually gives me that actual point that I need, right? It says the mean is the balance point of a distribution, and it's defined by distances, right? So it doesn't necessarily meet at the exact center of the scores. And since that's not the middle, it does represent the scores on an average basis, but it does not give me that middle point of the distribution. So if I'm looking for the middle point of the distribution, it's almost always best to use the median, right? Because it's defined by the number of scores that I have, and not based on, and does not serve as a balance point, right? Both measures are considered measures of central tendency, right? But you're going to use them very differently when we talk about the type of data that we have. And when you want to know the precise median, you're going to use that middle number, or the median, right? And again, we'll talk about different cases where using the mean is really, really important. And then using the middle number, or the median, is really, really important. And we'll talk about that. Okay. So in this particular case, I probably would not use the mean, because this is not the middle of the distribution, right? It does serve as, again, if I added these up, you got 1, 2, 3, 4, 5, 6 values, right? You got 3 2s, which is 6, 6, which is 12, And then I have, that's a 24. So 24, we got 2, 2, 6. That's 2, 3, 6. And then I have a 12. All right, so there's 12. And then you divide that by 24 divided by 6 gives me 4, right? So that's my average value. Okay. The average again does not represent the middle, right? So in this particular case, I probably want to use the median, because the median would then allow me to identify the exact middle of the distribution, which might be somewhere around here, right? So even though I have that average, it does not represent the middle, right? So the median would probably be best, especially when I'm dealing with an outlier that lies all the way out here. Okay. All right. So again, you do the true and false. So is it possible for more than 50% of the scores in a distribution to have values above the mean? In this particular case, this would be true or false. And I'll let you pause and then go. Okay. Second is it possible for more than 50% of the scores in a distribution to have values above the median, which is false. First one is true, false. True. The second one is false. Okay. So you can have more than 50% of the scores in a negatively skewed distribution, right? That'll be above the mean. Okay. But for the median, you cannot, right? It's based on the number of scores, and you have to have 50% of those of the distribution on the left-hand side or above the median, and 50% above, okay, below and above. All right, the mode. Mode is really, really simple to calculate, right? The mode is the score or the category that has the greatest frequency of any score in the frequency distribution table, right? It can be used with any scale of measurement, right? And it corresponds to an actual score in the data, right? So when you get the mode is the mode, right? It is possible to have more than one mode, but especially if there are two scores that have the same frequencies, right? So if I had two scores who had frequencies of 5, then those would be the two modes in that particular case, right? And then you have, in an instance, you might have one that has a maybe a mode of 5, and then you have another that has a peak or mode of 4. Then you might have a major mode and a minor mode, and we'll talk about those as we move forward. Okay, so here are instances where you have a major mode, where we're looking at the frequency here, student achievement scores. Let's say this is a ACT score, right? We have 7 individuals in this distribution who have a frequency of, a score of 22, and we have 6 students who have a score of 17. So in this particular case, the modes are not the same, right? But they are close enough where you see in this distribution where this is the peak, right? In this particular distribution, that'll be your major mode at 7, and then your minor mode would be at 6, right? So you do see that there are 2 modes. One is just the major, and one is just classified as the minor, okay? But this is a bi-modal distribution, okay? In a symmetrical distribution, okay? In a symmetrical distribution, you're going to have various ways in which you calculate the mean, the median, and the mode, right? So for a symmetrical distribution, the mean and, the median will have the same value. And if there is exactly one mode, it has the same value as the mean and the median. So the mean, median, and mode will all be the same. If you have a symmetrical distribution, say it's a normally distributed curve, you'll have a mean, median, and the mode will all be the same value, okay? Thus, it says in a perfectly symmetrical distribution, all 3 measures, the mean, median, and the mode will all be the same. And I'll show you an example on the next slide of those things, okay? It says a distribution may have more than one mode, like we talked about before, or no mode at all. So let's look at some examples. In this case, we have a normal distribution, so bell curve. The mean, the median, and the mode are all the same in diagram or figure A, okay? In figure B, you have 2 modes, okay, because you have a bimodal distribution. And then your mean and your median, since this is a symmetrical distribution, are the same. Your mean and your median are the same, located here in the middle of that distribution. Okay. And then we have here a mean and a median. Again, it's symmetrical, right? But we have no mode because, again, all of the values here are the same. So there's no mode for this rectangular distribution here. Okay. So again, these are distributions that are symmetrical, but again, the values of the mean, median, and mode will differ based on the type of symmetrical distributions that I'm looking at. All right. All right. So when you're thinking about skewed distributions, okay, skewed distributions, your mean and your median and your mode will have different values. Okay. When you think about a skewed distribution and all of your extreme scores are, let's say, to the left, or you have some extreme scores to the left, and this gets in a negatively or even a positively skewed distribution, the median is going to, excuse me, the mean is going to be shaded more towards the tail of the distribution, right? So when you see a mean, median, and mode, the mean is usually going to be scaled or shaded more towards the tail of the distribution. I'll show you an example on the next slide. Okay, the median, in order to divide again those scores in half, is going to be again right in the middle of that distribution, and it will fall between the mean and the score for the mode, and I'll show you what that means. Okay, but the mode is found near, again, the short tail of the distribution or the peak of the distribution for that negatively skewed or positively skewed distribution. And again, it'll be good to show you an example of that, okay? Here is a way that you can determine whether a distribution is positively skewed or negatively skewed. If you subtract the median from the mean and it is greater than 0, then that means that the distribution is positively skewed. That means, let me show you an example. Let me see if I can get, let me do this real quick. I'll just draw it. Okay, let me share. All right, so if I'm doing a positively skewed distribution, okay, then this will be my mode, okay, because it has the highest number of frequencies here. This will be my median because it is in the middle of that distribution, and my mode, excuse me, my mean will be to the right of that, right? So the median will always be in the middle. Your mean, if it's positively distributed, excuse me, will be and fall towards the side here, okay, towards the tail, and then your mode will be fall towards the shorter end of that tail right there, okay. The other will happen for a negative distribution, okay. So this will be my mode, okay. You have your median right here, which is in the middle, and then you have your mean. Okay, so what it's saying here is if you subtract your mean minus your median, oh, excuse me, let me do this. Median, and it's greater than 0, right? That means my mean is greater than my mean right here is greater than my median. That means it's positive. If my mean minus my median is less than 0, that means it's negatively skewed. So there's negative, positive. Okay. All right. So again, you can see I got my mean right there. If I subtract my mean on this, again, this is the number line right here, right? So everything to the right is more positive. Everything to the left is negative, right? So my mean minus my median is going to be less than 0. Okay. And so I'll give you and be able to show you an example of that in class on Monday. All right. Let me stop sharing, go back to my slides, and then we can go ahead and finish up. All right. So again, mean minus median greater than 0, positive distribution or positively skewed. Mean minus median less than 0, and the distribution is negatively skewed. All right. And this again is what it looks like. All right. So you can see it right here. This will go from, again, 0 to infinity out this way. So again, if my mean minus my median is, again, greater than 0, right? So this value of the mean is greater than this value of the median to the left of it, then that will be a positively skewed distribution. If my mean minus my median, so the median in this particular case is greater than my mean, then that would be a negative value, which would mean that that's a negatively skewed distribution. So if I'm given two values, all I have to do is look at the mean and the median. And if one is greater than the mean, it's positive. Excuse me, if it's a positive number, it's a positive. If it's a negative number, it's a negatively skewed distribution. All right. So here's an example, right? So if I have a mean of 31 and a median of 43, 31 minus 43 is a negative 12, right? A negative value gives me a negatively skewed distribution, right? So you're taking your mean, you're subtracting your median from it, and then you should get a negative number. If you get a negative number, then you get a negatively skewed distribution. Okay. All right. So here is an instance where, again, in 3.6, 3-6, when you would use, and when it's appropriate to use, a mean, the median, and the mode, okay? When you are looking at values and you're looking at scores, and you have all of your scores in the distribution, it's very, very easy to calculate the mean, okay? Very, very easy to calculate the mean. You know the value of every score in your distribution, right? It would be really misleading to use the mean in these cases, right? If you're using, you have extreme scores, again, like if I had all of my values were clustered around, let's say from 5 to 10, then I had one student score a 25, right? That would be very, very skewed towards that 25, and it would be very misleading because it's an extreme score. Skewed distributions, like we saw, the median is going to be pulled more toward the longer tail of the distribution. And so it wouldn't be kind of misleading. Undetermined values, if I've been recording something for, let's say, time, right? And I was unable to get a measure for someone because they just didn't finish the task, right, in enough time, then it's an undetermined value. Then it's just not defined. I got scores for everybody else, but I had one individual that did not complete the task in a timely fashion, and it was just over time, so they did not finish it. Then that would be an undetermined value. Okay, open-ended distribution means, say I have, say I'm looking to see how many people have tattoos and the number of tattoos they have, right? So I have individuals who have one tattoo, two tattoos, three tattoos, the number of individuals who have four tattoos, but then anything five or more, anybody who has five or more tattoos, they'll go into that one category. So that's an open-ended distribution because five or more, you have individuals who have five, and then you might have individuals who have 25, right? But again, it's an open-ended distribution because individuals on the that bottom interval, that class interval of five or more, you can have a number of individuals who have way more than five in that distribution. That means it's open-ended. Ordinal scales, obviously, you're ranking individuals from least to greatest, and then nominal, which is categories or names of categories. All right. When you're using the median, it's best to use them and more appropriate to use them when you have a lot of when you can't use the mean. It's almost more important and more useful to use the median, right? So extreme scores, skewed distributions. We saw that the middle of the distribution was the median. Undetermined values, you can still locate the median just by looking at the number of scores in that frequency distribution table. You can also look at an open-ended distribution and then also an ordinal scale, okay? You can use the median for those things, okay? And it would not be helpful to use it for a nominal scale because obviously, they're just discrete variables. And again, we know with discrete variables and categories, there's no need in using those, okay? The mode is oftentimes used for instances where I can't Again, these are discrete variables, right? So nominal variables or categories, discrete variables, and when you're describing the shape, right? So again, we talked about it before. If it's a symmetrical bell curve, all of my values for the mean, the median, and the mode will be the same. There'll be some instances where I can't really describe the shape because in that rectangular symmetrical distribution, there was no mode because all of my values had the same mode. So it was too many modes. They all had the same value. All right. But again, you would not use the mode for interval or ratio data because again, you have interval and ratio data oftentimes is going to have and be continuous. So it's no need in using the mode because again, there are fractional parts or the values are broken into fractional parts. So you would usually use the mean or the median in that case. All right. All right. One last thing that we talk about when you have large gaps in your data. So in this particular case, the number of errors, let's say for a memory quiz, right, and ranges from 0 to 100. We didn't have anybody that made any errors from 0 to 9, but starting at 10, one person made an error. You had 4 individuals make 11 errors. You had 3 people make 12 errors. One person made 13 errors, right? And then you didn't have any errors after that, right? From 14, 15 and on. And then we had one individual who made 100 errors, right? So that's a very, very special case. So what they did with this little break here is they created a little blip there, which then, again, made sure that we captured all of the data, but now you can still capture the data for that individual who had 100. You still want to capture them. You don't want to exclude them, but you do want to be able to fill in that gap and not have to list out 15 to 100, because again, that would be a very, very long number line from 0 all the way to 100. Okay. This is an instance where we're looking at the mean food consumption and drug dosages. So this is a line graph, and this would be really appropriate for a mean. So you have individuals who have a dosage of 0, right? Their food consumption was 20, right? Drug dose of 1, right? Their food consumption was a little greater than 20. Drug dosages of 2 and 3, you see the decline. So as you increase the dosage of that drug, there is a decrease. I guess this is an appetite suppressant type drug. So increasing in the drug dosage decreases the mean food consumption. So again, the drug seems to be working based on this line graph. All right. Here's an instance where you're using medians, right? Bar graphs. Okay, this is you have categorical data or nominal data here. You got preschool, kindergarten, elementary school, middle school, secondary school, and then you have teaching assistants, and this is teaching position, right? So the median income or weekly income for preschool, kindergarten teachers is probably around 650 or so, 670, maybe about 700. You have elementary school, it's right a little bit greater than $1,000 per week. Secondary schools is a little less than $1,250 per week. And then teaching assistants make around $600 per week, right? So again, you have a bar graph, you have nominal data, and you can still use, again, median values for that. It's just continuous variables with a nominal categorical variable. All right. So you have true or false. It says the mean uses all of the scores in the data, so it is best measure of central tendency for skewed data. And we just learned when it was appropriate to use mean, when it was appropriate to use the mode and the median, okay? So that wouldn't be false, okay? It says if the mean and the median have the same values, the distribution is probably symmetrical, and that would be true, okay? False for the first, true for the second. All right. These are practice problems. There are 3 of them that I gave you for chapter 3. So what you're going to do for the first one, you're going to find the mean, the median, and the mode for the following scores. All I need you to do is, again, find them for, again, this is for discrete variables in this particular instance. So based on the relative values for the mean, the median, and the mode, what is the most likely shape for this distribution of scores. And so now you're going to use, where the mean, the median, and the mode lie on the distribution. Now you're going to help me determine whether or not it's symmetrical, positively skewed, or negatively skewed based on the values for the mean, the median, and the mode. Very, very simple. Okay. This one right here is going to have you do the same. Now we have a frequency distribution table with your scores on the left-hand side, and you have your frequencies on the right-hand side, right? So you're going to have to find your mean, your median, and the mode based on these frequency distributions, right? So I had 2 5s, I had 5 4s. So in this particular instance for your median, you're going to have to, again, write out all of these values and then determine your mean, your median, and your mode. Mean shouldn't be too difficult. Your mode shouldn't be too difficult. The median would probably be the most difficult thing. And then I also need you to, based on your 3 values that I get for your mean, your median, your mode, what is the shape of the distribution? All right. This last piece is I want you to find the precise midpoint of the precise median for these number of scores. You got 10 scores. I need you to find that precise median. So the interpolation formula that we saw on the slides, I need you to go back there. Let me go back. We want to use this value or this formula right here. Let me go here. You're going to use this right here. Okay, you're going to use that formula in order to calculate that precise median for this right here. Okay, again, just practice. Please practice. I'm going to, again, 25 points for completion. So go ahead and get this done. Again, very, very, very easy assignment. Again, mean, median, and mode. You all should know how to do that. Again, the only tricky part will be this one because, again, you have to then list out all of your values for your frequencies in order to determine what your median is. All right. All right. That's all I have. That is the rest of chapter 3. And again, go through these, go through the slides. Take any notes that you need. We'll cover a few things on Monday. I'll show you in class how to do a precise median. But then after that, we're moving on to chapter 4. Just be mindful that we do have an exam coming up next Sunday. That'll be the 15th of September. So next week we'll cover chapter 4, and then we'll move right along. Again, if you need anything from me, again, I have office hours Monday through Thursday. Monday and Wednesday from 12 to 2 p.m. and then Tuesday and Thursday from 9 a.m. to 12 p.m. All right. You all have a great weekend, and I will see you all on Monday. Take care.